So, okay, this is my defense. Student Shamil Nartai, group SC 2327. So first of all, I'm gonna defend first task in Fuse assignment. It's about identifying MAC and IP addresses. So basically, main goal of this lab is to understand how data moves through a network and how devices use MAC and IP addresses, and also how these addresses change depending on whether the communication is local or remote. So the purpose of this lab was to observe how a protocol data unit travels inside a local network, then to observe how it travels between two different networks through a router, and the last, to identify when and where MAC and IP addresses are changed during the process. So in the first part I worked with two computers in the same network, PC1 and PC2, with different IP addresses connected. They were connected through a switch and a hub. Here is the image. So basically, first of all, I opened the command prompt on PC1 and send a ping to PC2. Here you can see it. Then in simulation mode, I switched to simulation mode and I captured each step of the PDU moving through the network. At every device, the PC, switch, hub, and also the destination PC, I checked the PDU details to record both MAC and IP addresses. Here you can see it. The results showed that the MAC addresses were used for communication within the same local network. The IP addresses did not change because the devices were in one subnet, and the switch and hub only operated at the lower layers. The switch used the data link layer, that means it used second layer, and hub used first layer since it only repeated signals on the physical layer. So here you can see it, and also you can see my observations. Okay, moving on to second part, remote network communication. In the second part, I studied how packets travel between two different networks, from PC1 to PC2. Well, here a router was used to connect the two networks. Also, I provided a little scheme of the process. Okay, so basically I reset the simulation and again send a ping command from first PC to this ping. So basically I pinged another PC. Then I captured steps, observed the first PDU, and recorded the data. The key observation here was that the router changes the MAC addresses when the packet crosses from one network to another. However, the IP addresses remain the same from source to destination, which shows that IP works at the network, which means it works on third layer and provides end-to-end communication. So basically that's all, and also I provided screenshot of the outbound PDU details of each device. Here you can see it, and in the end I provided the reflection questions. So in conclusion, I can say that this lab clearly demonstrated how MAC and IP addresses work together to deliver data in computer networks. So the MAC addresses operates at the data link layer, ensuring delivery within the same network. However, the IP address operates at the network layer, ensuring delivery between networks. Also, when data crosses a router, only the MAC addresses change, but the IP addresses stay constant. So basically, thank you for listening. Now let's move on to the second task, this one. So second task was about configuring initial router settings. Objectives of this lab was to verify the default router configuration, configure and verify the initial router configuration, and to save running configuration file. So in this activity I performed basic router configuration tasks using Cisco IS commands in Packet Tracer. Okay, so let's begin. At the beginning I connected the PC to the router using a console cable. Here you can see it. I opened the terminal on PC and established a console session with the router. After pressing enter, I received the router prompt and entered the command enable to access the privilege access mode. Here you can see it. Then I used the command show IP interface brief. You can see it a bit lower. Let me show you. Here you can see it. And from the output I saw that the router had 4 fast Ethernet interfaces, 2 gigabit Ethernet interfaces, and 2 serial interfaces. I also checked the VTY lines here using show running config section line VTY, which showed a range from 0 to 4. Finally, I entered show startup config and the router displayed startup config is not present. This meant that no configuration had been saved to NVRAM yet. So first part confirmed that the router was using its factory default settings. Here is the answers for the questions, but also I provide them here in a speech, but I thought that it would be like more useful if I also provide them under the tasks. So let's move on to second part. In the second part I configured several important parameters. First of all, I set the host name to R1 using the command hostname R1. Here you can see. Then I created a message of the day banner with the text unauthorized access is strictly prohibited. This message is used to warn any unauthorized users and serves as a legal notice before login. Next, I enabled password encryption using command service and password encryption. This ensures that all plain text passwords are stored in an encrypted form in the configuration file. After that, I configured 2 privileged access passwords, an encrypted enable password, which is Cisco, and encrypted enable secret password, which is a secret. I also set a console password by entering the line configuration mode with line console 0. Once all settings were complete, I exited configuration and configuration mode and verified everything with show running config. I could see that the host names were right here. It's hostname R1, passwords also were encrypted, and the banner was active. To test this configuration, I disconnected from the console and reconnected again. Upon connection, the router displayed the warning message and it asked for the console password. After entering the password, main, I reached the user access mode. Then using enable and typing it's a secret. Okay, let me show you. So it's here. Okay, then I used enable and typed it's a secret, and I successfully accessed the privileged access mode. This verified that my configuration worked as intended. Okay, let's move on to the third part. Saved running configuration file. So in third part I saved my configuration so that it would not be lost after a reboot. The command I used was copy running config. Here it is, startup config. This copied the current running configuration into NVRAM. As an additional backup step, I also saved the configuration into the router's flash memory using copy startup config flash. After verifying with show flash, I saw that the file startup config was successfully stored alongside the iOS image file. It is here. So also during this lab I answered the theoretical questions as well, but as I told previously, I provided the answers for these questions in my speech also. So in conclusion, to summarize this lab, in this lab I successfully connected to router through the console, verified the default configuration, configured the host name, banner and passwords, enabled password encryption for security, tested both user and privileged access logins, and saved the configuration to NVRAM and flash memory. This activity helped me to understand how to perform basic router configuration and also how Cisco IOS stores settings and how to secure access to network devices. And at the end, you can see that in assessment items it showed me that every step is included and I completed this lab perfectly. So thank you for listening. Goodbye.